Good evening, gentlemen. Our next topic for the evening is the sustainability adoption in the electronics industry. And it's my pleasure to introduce Venkatesh, Senior Director with Silicon Labs, board member of TI Hyderabad. But what is very interesting about him, for those of us who use Wi-Fi, he's one of the people who's been instrumental in coining the term Wi-Fi. He's been in the industry for 35 years and has been a pioneer in wireless and IoT. With that, welcome, sir. Over to you.
Thank you, Gaurav. Well, centuries of human advancement and technological innovations have happened before semiconductors were invented. But today, we cannot really think of any kind of advancement without the use of semiconductors and electronics. I mean, at Silicon Labs, we create chips that power smartphones, smart energy, smart lighting, smart healthcare. We can't imagine how the rest of the world would get on without chips like what we and other companies do. Agriculture, water conservation, energy management, and pretty much all of what we've been talking about in this summit are powered by electronics. In this panel, we will talk about some of what all of this is all about. We will hear it from leaders in this field. So in the spotlight tonight are Sambit Sahu, Vice President of the Network and Edge Group and General Manager of the IoT Engineering Group at Intel Corporation, Satya Gupta, CEO of Seedeyas Innovation, and Bhaskar Rao, CEO and MD of IRAM Technologies. Sambit Sahu is an industry veteran, having delivered more than 70 groundbreaking products and technologies that have fetched in more than $100 billion in revenue. He's worked in the US and in India, and prior to Intel, he's been with Qualcomm, Sun Microsystems, Pocket Networks. At Intel, he leads the worldwide engineering team responsible for product design and development across IoT, intelligent edge, AI client, and networking products. Sambit, please tell us a little bit more about yourself.
Thank you, Venkatesh, for the kind words. And I'm based out of Bangalore, and I lead a worldwide team working on IoT, AI, edge, networking. These are great technologies for the future. There is a big revolution happening as we speak on all these technologies. And I'm really very glad and proud about the Sustainability Summit. This is a very eye-opener for all of us, that while we build technologies, we have just make sure that we are also good corporate citizens and we do the right things for the world. Thank you.
Satya Gupta has been a techno visionary and a part of the worldwide electronics and semiconductor industry for more than 30 years, both in the US and in India. He has been in semiconductor product design and wireless, SoCs and high-performance computing, and in manufacturing involving fabs, packaging and manufacturing services. He has been one of the founding members of the India Electronics and Semiconductor Association and was its chairman twice. Satya, do tell us more.
Thanks, Venkatesh. I think I don't want to say too much about myself. Been around for 35 years in this industry. After a long corporate and startup life, now I'm devoting my time to basically create a ecosystem where Indian electronics prospers, products can be developed and basically scaled up. On the other side, basically addressing the problem like air pollution, water pollution are some of the basically areas done work, and those are some of the passionate area other than medical electronics and so on and so forth. So currently we are working on an initiative in the public space to develop few important national product using electronics. Soon we will announce this initiative to the rest of the guys. Thanks.
Bhaskar Rao is also an industry veteran of over 30 years in telecommunications and electronics. He has helped shape the telecom of today with contributions to specifications and standards. He is now the founder and managing director of IRAM Technologies, a startup working on smart city solutions. Uday, we would like to hear more from you.
Yeah, thanks, Mr. Venkatesh. I've been in this industry for almost like 33 years. I started my career with Telecom Technologies, starting from CDOT range of systems to DWDM systems. last my stint was at the DWDM with gigahertz of speed. After that, I moved into this startup ecosystem, right, where I wanted to start the IoT-based systems. So we have started this startup called IRAM Technologies Private Limited with like-minded people, and we developed technologies locally in India for sustainable cities, mainly, and in the range of actually smart parking and smart lighting solutions. And we deployed these solutions over 10 smart cities in India, and then we are promoting these products even across the world also through our partners. That's a brief introduction of mine. Thank you.
Thanks, everyone. So, Sambit, we've all seen the explosion in the use of electronics and IT in all areas, and all of these consume energy. And in some cases, like data centers, enormous amounts of energy. So, electronics causes consumption of energy. But in what ways are electronics, which are powered by semiconductors, helping to reduce energy consumption?
That's a great question, Venkatesh. And by the way, this is one of the most actively researched topics. Let's understand why this is happening. I think there's a big technology revolution happening. The three main technologies, that's IoT, AI, and the communications technologies like 5G, all coming together. They're all coming together and they need massive amount of computing. The number of IoT devices is growing from 30 billion to 75 billion by 2025. The amount of data that we need to process is growing from 40 zettabyte to 180 zettabyte by 2025. And as we speak, there is just humongous amount of AI processing and AI applications getting developed. And the fundamental computation of AI, which is neural network, today it is 1% of the human brain. So there is so much of development needs to happen, and this will require a lot of computation, a lot of power. And many companies are trying to see how do they solve it. Now it's no more only a semiconductor solution. It's no more that only semiconductor company need to solve. There is an interplay of systems, software, process technology, semiconductors, networking, all coming together to solve this. For example, in the system software, we should first look at use cases and workloads. How do we optimize that for power? How do we make sure that those workloads, we give them the right number of CPUs, the right frequency, the right voltage, the right amount of memory for them to process, and having the right balance of quality of service and power. Okay. Also, in this widely connected world, we need to figure out how do you orchestrate between your IoT devices, your edge computing and cloud that gives you the right balance between quality of service as well as power. And there is a lot of video content coming in, and the video content needs to be compressed. We need to have the right data formats, all those things. Otherwise, they will consume a lot of power. So, a lot of activities happening in use cases optimization, workload optimizations, orchestrations between the edge, cloud, and device. Now, when I look at process also is improving. Of course, we'd like to improve better than what it is today. For example, TSMC, from 7 nanometer to 5 nanometer, we see a 40%, or estimates of 40% power reduction at ISO frequency. Now, this, as I said, there's a lot of AI processing, AI computers happening, and that is happening in the data center. And a lot of new technologies coming in the AI. AI is evolving. Things like we are now looking at ASICs for AI, like the Google TPU or the Intel Movidius, which can really optimize for power quite a bit. Similarly, there is a concept called tiny ML. Tiny ML is basically adding some amount of intelligence to your microcontrollers, to your sensors or actuators that are very close to the user. Because if you send all that processing to the cloud, that is massive amount of bandwidth, that's massive amount of power in transferring and processing. So this tiny ML is evolving, and the tiny ML is supposed to go to around 2.5 billion devices by 2030. And there is also a spiking neural network that is evolving. Today's neural networks are pretty much based on mathematics or mathematical model. The spiking neural networks are mostly like, they correlate or they're very similar to human brain. They are biologically inspired. And their power efficiency is probably 1,000x more better, 1,000x better than the mathematical model-based neural networks. So a lot of this technology involving neural networks. And in silicon design, there's a lot of action happening in disaggregation technologies, because we can take a big piece of functionality, break it down into smaller components called chiplets, and then you can process the chiplet based upon the performance power needs in different process nodes. So for those functionality which don't need as much performance, we can utilize a lower power process. So this disaggregation technology also is picking up. And in networking, I think with 5G, it's expected to save 90% network energy over 4G. And also a lot of new wireless technologies like low power Bluetooth, low power wide area network, Zigbee, and all these things that are evolving to reduce power. So, as I said, it's no more a semiconductor play. All this interplay need to happen. Everybody needs to do their part, and that's what. But this is a massive problem. The amount of AI processing happening right now and going to happen in the future, we have to pay serious attention to it.
Yeah, I mean, it's fantastic. I mean, I know that even if software engineers are being trained to write code that would consume less energy than before. It's truly again all-encompassing solution which we are all trying to address. I'd like to ask all of you. I mean, you've spoken about so many of these technologies and so many of these chips and wireless and IoT and so on. But we are talking about a complete smart society now. IoT-enabled, intelligence-enabled, computing-enabled smart society. Is this a solution, the smart society? Is it going to give us a solution for better energy management, better health, better overall sustainability? So what aspects have you looked at closely? Let me ask each of you in turn. Satya, so what have you looked at in this smart society area? What do you think are going to be the path-breaking things from what you have seen? Can't hear you. Satya, you're on mute.
Yeah, particularly I'll take to basically give a wider perspective on the interplay between technology and sustainability, right? Basically, so if you look at a lot of the problems which we talk about, either environmental, climate change, and all those things, right? They're a combination of basically technical advances and basically human behavior, right? When both of them basically combine in a negative direction, then basically you create all the problems. Right? But at the same time, if you combine both of them in the positive direction, right? Use of technology and good human behavior, you can solve basically most of the problems which basically face in terms of the sustainability today. So, for example, if you take air pollution in cities like Delhi and others, right? It is a combination of basically technology advances, that so many cars, so many basically construction, and so many so forth. Plus, basically, a human factor also is involved, because our farmers in basically western region will not basically stop burning the parali, right? That's more of a not technically advanced thing. It's a more of a human behavior. So, but at the same time, if you take right use of the technology, for example, basically right kind of outdoor filtering devices, right, which can learn something from the electronics and semiconductor, that basically you create a distributed system, right? So just like you create distributed system for internet and network, if you create a distributed system of filtering devices throughout the city, right, then technology can help in solving the problem, right? Combine it with good human behavior, and then you create a basically a sustainable society. Second point is that if you look at every system, large system like electricity system, water system, any such large system, right? There is typically huge amount of wastage, especially in country like ours, because they are still basically upgrading our infrastructure, right? I think technology can leapfrog to address this wastage of energy. Like people say, if you basically by the time from energy generation to energy served, right, you lose somewhere around 60 to 70% of energy, right? Now, use of the technology can be instrumental in basically smart society to reduce this wastage. Similar numbers are there for water, right? You never know where the leakage in a city, right? If you plug all the leakage in the city, probably you will double the water availability, right? Now, technology can detect where the leak in the system and so on and so forth, right? And certainly the sensor technology, the control technology, which is ultimately powered by electronics and semiconductors, can basically impact these large systems, which basically can help in creating a sustainable society. Thanks.
Wonderful. Yeah, I think that's a great perspective on how these interplay and how the human element also comes in. So Uday, you are working in your startup is focusing on smart society, smart cities. What way do you think the technology that you're working on and the solutions that you are bringing out, solutions like that, how do they actually impact sustainability? What's your perspective?
Yeah, I'll take a cue from Satya. I think he has just created a stage for me properly. So the solutions were, when we devised the solutions, when we advised the solutions for the smart cities, right, way back in 2014, many believe that these solutions are just only hype and they are not going to be useful, right? And I think it is just only the government is creating something which now use at all. But really, when we started deploying the solutions and the results are coming out properly, and that is showing a lot of change. I'll take an example of environmental sensors. Okay, we have deployed these sensors across the cities. Actually, right, we have done in Sahu and in Kanpur, Bhubaneswar, and these other places. So when we deployed these sensors, people asked, okay, this used to be normally in one of the airports, and then that's all actually, right? Nobody going to use it. So why do you deploy these things? But when we see these sensors deployed in Kanpur across the roads, and each road, right, is measuring its parameters and then shown, people are shocked actually. And they go to the government and then they say, Commissioner, oh, what is this? My area is polluted. So can you help us? So then government has to rethink, is it the right thing to do this, actually show it all these parameters to the people? And they go and digest. And when they come back and then say, okay, let us do something, right? Okay, let us avoid some traffic in this road. And this is polluting a lot. Can we see some change? So then they came and then asked us, okay, give us the data, right? Maybe for a period of last 1 month or 2 months, what we observed. What is the data, and can we do something for that? Even they ask the solution also. Even though we are not experts, but we give them actually, you can reduce the traffic here, or you can stop the generators usage, or you can run them actually in the nights actually, right? So these are good things which will definitely increase, right, the air quality levels and people's acceptable levels also. So with that, actually, right, there is a drastic change in the cities. A city like Dahod, which is not known to anybody actually, right? In India, I think maybe most of you might have not even heard about the city. It is there actually in the border of Madhya Pradesh and Rajasthan. There, we have seen a lot of change actually happening. Actually, the people are questioning. Actually. So this is good system. Why can't you make it permanent? And then since we have developed it as a trial basis, and they made it actually permanent. Actually. And the similar way, the lighting, right? When we go with LED lights changes, right, from the normal conventional lights, the adaptability of those lights and then the power consumption of that shows that, okay, that it's a good development for the city, and it gives a cool light, and it reduces the heat also in the night. Actually. So you can compare actually what was there earlier and then currently, and that shows a lot of change actually. And the municipalities have saved the power, almost like close to 80% power is saved actually in some cities. And if you see actually that in Bangalore city, where we are going to deploy about 5 lakh streetlights by LED, the operator or actually the contractor has claimed that he can do almost like 80% of power saving, which is great actually, right? So city like 5 lakh streetlights are going to be like lit up, and that power consumption is definitely right, is going to lower your power consumption or power generation in India. By seeing all these, actually, right, the government has come up with even village levels, and we are now working on the small towns and then cities levels in Madhya Pradesh. And there, I think, if you take the totally right, they are going to be about 20 crores, 25 crores street lights are going to be changed by the LED lights. And with this, you are going to see a lot of reduction in the power generation than actually, right, the power generation required earlier. If you observe, I think in Hyderabad recently, maybe somebody would have heard about, right? I think, in Andhra Pradesh, they're going to give the money back to the users, I think, because we have excess power generation. And this is what is expected actually from a country like India. And the Prime Minister's vision was actually, right, he wanted to do about 170 gigawatts of power generation by 2022. And it's almost achieved, right? And more than that, I think it is achieved. And his next target is about 450 gigawatts of renewable energy by solar and other means. And that's anyway, it's going to happen. So to come back on the solutions, whether they are working or is it going to help the people? Yes, they are. And we need to do a lot of this deployments across the cities, multiple cities. It's happening at a very slow pace because of various reasons. Maybe it is because of the money, budget, or various reasons. But once this is done, I think the cities are going to be a sustainable cities. And recently, you could have heard about Bhubaneswar, right, or Orissa, claiming that they are going to give a water in a tap. Actually. So, I think the Chief Minister himself claimed that, okay, I can bring the tap water myself, which is almost equal to the Singapore city. So, if a small city like Bhubaneswar, very less known, can do it, why not the other cities actually? So, if he has achieved that, I think he could have done a lot of the wastages would have arrested in between the water processing and generation up to the delivery at home. And the quality also is maintained. So these kind of solutions, the smart solutions, are going to play a major role in Indian smart cities and Indian people also, the societies.
Absolutely. I think everybody needs to hear these stories. These are success stories which I feel should reach a wider audience. So that's why I try to do that, because people can get inspired to do things similar. So Sambit, do you feel, is a smarter society the road to better sustainability? What do you think?
Yeah, first of all, great point, Satya and Uday. And Uday, my hometown is Bhubaneswar, so very proud to hear this. Okay. So first of all, I will touch upon 3 points. I just want to give you one statistics. The cities, early 20th century, the percentage of people living in cities was 15%. Okay. In 1901, percent people living 15%. Now 54% of the population living in cities. And by 2050, it will be around 67%. That means 2/3 of the people will live in cities by 2050. The cities only occupy 2% of the Earth's surface area. Now you can imagine the problem space. 2/3 of the population living on 2% of the Earth's space. Okay, so which this means that we have to use technologies to really do great planning of smart cities. And I'm really glad that the smart cities are really picking up, and they shared a lot of great examples. And there are a lot of good technology, the digital twin technology, the AR, VR, all these things. It's important to plan the infrastructure. Without proper planning, it will not happen. So we need to really do proper planning. The second piece is that we can't underestimate agriculture or the food. So we have to use technologies, which is happening as we speak, drones and IoTs and sensors, of how to do very precision farming, how to increase our crop yields and things like that. And third piece, which I don't want any of us to underestimate, with all this AI happening, coming up, ethics, integrity is very critical for society. AI is a great tool, but it's a double-edged sword. Okay, I can train an AI with certain models and pictures where I can bias it against certain society, certain set of people, and all these things. We have to be very careful against using AI and triggering biases, discrimination, or robots. Robots are great benefit, but they can also be abused or misused. Okay, so we have to be very conscious of ethics, integrity, and using technology in the right way for a sustainable society.
Yeah, absolutely. I mean, that reminds me that, there is a trend today, or at least there is a kind of an awareness happening on what is called ethically aligned design. We are all technologies, we can create whatever we think we can, but are we doing the right thing? Are we creating the right thing? So that's very important. Now, coming back to what the technologies that we are talking about, the TSS does bring in a lot of entrepreneurs, and I'm sure there's a lot of entrepreneurs listening in. So let me ask us, Uday and Satya, what do you think are the current advances that startups can use to create solutions for a more sustainable world? Satya?
Thanks, Venkatesh. I think in my last 17 years of journey as an entrepreneur, what I would say going forward, the advances in the sensor technology is probably the most important aspect in basically the type of application with Sambit and Uday talked, right? When we talk about basically smart city lighting, right? For example, you can get about 50-60% saving just by changing your sodium lamp to the LED lights, right? But whatever is LED light producing, do we really need that much to basically serve the road and society? I think that can be further reduced by another 80% by using the smart sensor and smart basically action based on those sensors. Because take 2-second diversion. See, on the road, where you need the most light is where the most vehicles are. Now, vehicles themselves are producing so much light that you don't need that much light from LED, right? Now, you can basically through sensors, you can optimize it and basically further reduce almost 80% consumption of the LED light itself, right? Similarly, you can do basically a significant optimization by using a smart parking, right? Typically, you to go to commercial road, people who live in Bangalore, right? You will take 10 to 15 minutes to basically find a parking, right? Now, in the smart parking technology, you can find that space in basically 1 minute, right? So then 14 minutes of the fuel is saved. Other than time basically saved, that's a different dimension, but at least your fuel is saved. So I think all of this technology, Sambit talked about basically smart agriculture, precision agriculture, right? Again, basically all of it based on the sensor technology, which are extended for electronics and semiconductors. You have optical sensors, you have basically proximity sensors, you have spectral analysis, so many different dimensions of sensing technology, which is advancing at a very fast pace. So I think one of the things our entrepreneurs in this space can do is that basically utilize the most advanced sensing technology to build their products and make them go beyond basically whatever they are capable to do today, right? Like hyperscale optic devices, right? Which can do the whole spectrum basically in one shot, right? Now your crop analysis can be done basically very efficiently using that, right? You can do milk analysis for adulterants so that the right type of the milk basically reaches our kids, right? There are no contamination, no adulterants, right? So lot of stuff ultimately depends on sensor. It's just like a body, right? Where electronics is your basically heart and rest of the organs, and your 5 sensors are basically these sensors around the world, right? By utilizing both of the things in a combined manner, you can create a better human body. That means better sustainable human society.
Amazing, amazing. Yep. So, Udai, so you are also an entrepreneur. So, what do you think entrepreneurs what technologies do you think they can use to address opportunities in this space? So, what are the critical things that's coming up that they can make use of and make their mark in sustainability of the future?
Yeah, actually, Satya has given a better introduction of my technologies. I think what he has mentioned about the lighting, yes, the smart lighting, what we deploy is with intelligence, actually. So it's called as an intelligent lighting system. And we use the sensors and the gateways for communication. And even though it is a small LED light, right? So we monitor the light on a almost like real-time basis and make it operate as what we need, actually, exactly. As we said, okay, if there are headlights coming in or the ambient light is there, or if there is a movement, then we can make them on and off. So because of those things that we were able to get about 80% of power savings. And similarly for parking, again, the same solution we do it. The parking sensors we do in India, and the parking gateways and getting connected to the network and make them operate when the car is there or not, actually, right? It will be seen through the network, and then based on that, actually, the commuter can take a call whether he can go in that direction where there is a parking place available, or he should avoid those directions actually in the place. Normally, right, if you get into MG Road in Bangalore, you cannot come out of it, at least for half an hour. So it's better that you see before going there itself whether I should go there or I should park it in a residency road and walk up to the MG Road. So these are definitely is very good technologies, right? So should be doing actually. And but as I said, okay, that right, these technologies, the sensors and other hardware, there is actually a very little interest in the companies, right, in India to do any hardware. That is very distracting, and it's a horrible for India. I mean, everybody wants to say, okay, I'm a software guy. Okay, let me do software development. I can do a software services or anything. I'm good at. But hardware, no, it's not my baby. And even investors also, right, they don't consider hardware as a right opportunity for them also. So that perspective should change actually. That's where myself and Satya and others actually we worked. And it took a long time for IRAM to come to this stage. We started almost 10 years ago. And to come to this stage, to sustain it takes time. And there's one more company called TSS also, right? So they are into telecom field, and they also struggled a lot, and then got into the stage. So first of all, actually, we should be encouraging atmosphere and the business environment and the ecosystem in India for the hardware to develop. And there should be availability of the semiconductors in India itself. Otherwise, currently, right, we are totally depending on either China or Taiwan, and that cannot go on actually. So now, if I have an order, I need to predict this and then order my components almost like about 3 years ago. Yeah. Otherwise, I cannot be supplying these components. And if I go and then buy everything online, then it is going to be expensive, and I'll not be cheaper than a Chinese vendor. So unless this ecosystem changes and the semiconductor availability in India doesn't happen, then the hardware manufacturing doesn't happen here. A country like India cannot have this kind of the smart cities in future.
That's a very important point you brought up. We are an ecosystem. We work together. Now, Satya has been the chairman of the India Electronics and Semiconductor Association. He has worked with companies here, bringing them together in one umbrella, and also worked with the government in order to influence policies. So how is the ecosystem cooperating here, Satya? So what's going on, and is the government receptive, and what ways are we jointly shaping the policy for better technology tomorrow?
Yeah, so I think thanks Uday for basically giving the right pointer. So you might have seen basically last couple of quarters there is a lot of upheaval in the media, sometime this, sometime that, and so on and so forth, right? So that certainly means basically things are happening. Okay, I think electronics and semiconductor today, based on basically informal conversations, are being basically handled at the highest level in the government, right? At a high priority level, right? But as a lot of people would like to say semiconductor manufacturing and fab because that's a glamorous thing, right? But effectively, if you look at any nation which has made basically serious progress in this area, the electronics products are basically the leading factor, right? Once you have electronics product, it creates the demand for semiconductor, then you have fabless companies. Once you have fabless company, it creates demand for semiconductor manufacturing. So it basically creates a demand for the fab. But since the gestation time for all the three things is basically a little different, so everything has to start in parallel, but by the time you reach to basically a mature fab, you have enough fabless companies in the country to consume the output of the fab. And by the time these fabless companies produce their products, you should have enough electronics companies basically which can consume this thing, right? The output. So if you look today, we have about $200 billion of basically electronics product consumption in the country. Now, you can basically look yourself, but if you look the contribution of electronics product, Indian electronics products in this $200 billion is about 5% or less. So when I say Indian electronics products, I mean Indian brands where basically the design, manufacturing, IP ownership, brand ownership, all of that basically in India. It's less than 5%, right? So if you don't have basically your own electronics products, right, you don't make a decision that what chip should I use. Okay. So then basically your fabless companies don't develop because of that, right? And if the fabless companies don't develop, means total consumption of basically wafers, 12-inch wafers by Indian companies in India will be less than couple of thousand wafers. Okay, that's not a basically huge consumption by any means, right? So we have to work on all the three ecosystems together: electronics products, semiconductor products of fabless companies, and the fabs. So in next basically 7 to 10 years, with the different maturity time of each ecosystem, they will start basically supplementing or complementing each other, so that we can have a comprehensive ecosystem. And government is exactly working in this direction. You hear a lot of news about the fab, but there is a 1,000 crore policy basically which is about to be announced for basically incentivizing the fabless companies. And the similar basically efforts are being happening both in government and private domain about creating the important and high volume electronics products like tablets, Wi-Fi routers, meters, e-passport, and so many basically important products are there which impact not just economy but the society at the large also. I think a lot of effort is happening. Now everybody understands that we need to interplay between the three ecosystems, and we need to look at all the three together to make a serious dent and make India in next 10 years a electronics product nation.
Absolutely, fantastic. We know that, okay, I mean, India is one of the fastest growing consumers of electronics in the world. The amount of electronics we all purchase is mind-boggling. We are a sink. Earlier, we used to be a sink for the world's gold. We are today almost a sink for the world's electronics. We consume and consume and consume. And like Satya, I mean, you perfectly mentioned that if we have to make a fab, then the fab should have an electronics company taking the chips and then using it to create products, and we need to have as much of our electronics that we consume to be manufactured in India as possible. That's absolutely one of the major goals. But it is true that it's not just in India that electronics is growing. Everybody around the world, and the pandemic has actually made it even more significant, consuming electronics. The pandemic has made the electronics industry see something very strange. Demand outstripping supply by multiple times. Today, many years ago in India, it used to be ration. You can use only 5 kgs of sugar a month. Now, fabs are rationing chips to companies. Car companies are shutting down, shifts, so because they don't have chips. They have plenty of steel, they have plenty of everything else, but they don't have chips. Now, what will be the effect of this? Semiconductor companies are going to ramp up production. They are going to ramp up production big time. And we know that manufacturing of semiconductor itself is a massive automated operation. It takes a lot of power. It consumes a lot of water. It potentially can pollute a lot. So Sambit, I have a question. Intel is probably the world's largest chip manufacturer. What's going into the manufacturing technology itself so that it can be more sustainable, less energy consuming, less polluting, and so on? What's happening here?
A great question, Venkatesh, and you put the background very appropriately. This pandemic is triggering a huge demand for chips and manufacturing. I've been with Intel for many years, though I'm in the design side of things, but I have some ideas about what happens in the manufacturing side of things and how do we handle sustainability. And you rightly said, the manufacturing is a very complex process and takes a lot of energy, a lot of water, chemicals, gases, noble metals, and there are side effects. There are side effects of depleting the Earth's resources, side effects of toxic material getting produced, side effects of how do you manage the waste, side effects of water problems. So a lot of side effects, okay? The good thing is that Intel and other manufacturing companies like TSMC, Samsung, and others who have fabs, they are definitely excellent corporate reasons. They understand this and they're very serious about the sustainability of this. Okay? And what they follow is principles of circular economy, which is the foundation is 4 R's. The first R is reduce. Reduce the amount of energy or water you want to, figure out ways how to optimize that. Second is reuse. Before throwing away a component and material, just see how you can reuse it. Third is recycle. Okay, when you have to throw away something, there are companies you can figure out how to recycle that and transform that into something valuable. And fourth is restore. When you are taking away the Earth's resources, you have to figure out how to restore it. Okay? And I can talk about Intel because I've been very closely associated with it. Intel has RISE goals for 2030. RISE stands for Responsibility, Inclusive, Sustainability, and Enabling. And in the sustainability piece, our goal by 2030, which is driven by the CEO himself, is 100% renewable energy, which has minimal effect on climate or CO2 emissions, and 4 billion kilowatt of energy conservation, and net positive water reuse by conservation as well as restoration, and 0 waste to landfill, and 10% reduction in scope 1 and 2 carbon emission, and have our products achieve 10x power efficiency. So these are our 2030 goals. We are definitely heading in the right direction. In 2020, we conserved around 7 billion water. We installed 100 renewable energy items. And also Intel is working with multiple countries to restore water, including helping Bangalore government, the government in Bangalore, the corporation in Bangalore to restore 2 lakes. Okay. Now, the good thing is that these sustainable practices are part of our executive compensation. We are measured how well are we doing with reference to our sustainable practices. There are thorough audit processes. We are active in many bodies and governance councils, and we're putting a lot of mitigation strategies to reduce CO2 emission, to reduce toxicity, chemical, how do we have green chemicals, and multiple techniques to minimize these side effects. And a lot of also research going on in design, in PCBs, and our display systems, our power supplies, how to reduce the CO2 emissions. So again, I just spoke about Intel, but a lot of other companies are doing something very similar. So this is a problem, but I feel the companies are coming together, taking the responsibility seriously to tackle this problem.
Amazing. I mean,
I can share some more data about this.
Absolutely. Go ahead. Yeah.
The TSMC has a goal of basically zero emission by 2050. Okay. No, basically net zero emission of 2050. But I think we are still dealing with power issue, right? Although almost 20-30% of our design budget goes into low power designs, right? And Venkatesh, you know about it because IoT is certainly very heavily dependent on low power devices and so on and so forth, right? But if you look, right, just like Moore's law, there is another data which is basically how many megaflops you can do per watt. Okay. And it used to be basically double the number of megaflops every 2 years till 2010, 2015. But last 7-8 years, that rate has become basically 2.7 years. Okay. Now, our Moore's law, because of the vertical integration and chiplets and other things which Sambit talked, right? It still continues to grow the computation at basically 2x per 2 years, right? But our energy is basically taking 2.7 years to basically reduce to half, right? So I think if you start plotting this exponential curves, right, we will have to do something about basically power consumed by these devices, right? Because this 2.7 to 2 years gap, a lot of people are basically engineers here. If you start plotting this graph, very soon you'll see big divergence, right? So whatever has happened in the industry to sustain the Moore's law, right, by doing the vertical integration, chiplets, this, that, all of those things, something similar has to happen in the power domain also. Okay, because our computing needs are going to surpass both of these, Moore's law and basically power law both. And if our power consumption by semiconductor devices is basically not catching up with basically computational scaling, right, then we will have a much bigger problem on the power thing. And
yeah, absolutely. Because
what Sambit talked earlier, that basically the only answer we have is that basically a different set of architectures than traditional von Neumann architecture for doing everything, right? Basically, now we are so closely interacting with physical systems, right, in our electronics and semiconductor, whether it's a spiking neural network or Sambit talked, or other basically be it quantum computing to solve the NP-complete problems. We have to start looking at basically other models of computation if we have to catch up with this power curve. Otherwise, this is going to be one of the biggest problem in growth of basically this technology and industry.
Absolutely. I mean, the smarter society has more sensors, more data, more computing, and unless we change the paradigm, go into doing something, I mean, people are talking about all kinds of artificial intelligence, which is throwing computation at a problem and hoping that it will solve itself. And that consumes a lot of energy. And then the technological advances that we have in improving the way in which you are doing those algorithms, maybe eventually leading up to quantum computing. I mean, we have faith in our engineering community in the fact that the problems can be solved. But even so, energy is still, is something that will always be scarce in demand. I'd like to ask one final question to Uday. So what about solar? I mean, India, has a lot of sunshine, a lot of things. What do you see? I mean, do you think startups can start looking into solar innovation, energy harvesting? What are the things that they can do some of these?
Yeah. So as a solar, right, the target by the government and the Prime Minister itself, right, he has mentioned that about 450 gigawatts of power to be generated by 2030, and around 100 gigawatts, right, has to be generated by 2022. I think out of that, already 170 is done. So out of that, if you see a bigger company, like when you mentioned about the startups, right, I wanted to give this example. A bigger company who is actually a promoter of this event itself has done about 15%. But other companies are just catching up. They are doing it also. There are multiple. But when you look at that, actually, if you see the solar panels production in India, it can just sustain only for 2 or 3 gigawatts of power generation in a year. This was actually a status, right, about a year ago when I checked. But all over India, the production can happen maximum only for 3 gigawatts. But we are talking about 450 gigawatts by 2030. And we talked about, right, 170 gigawatts by 2022. So where all these things have come? These things have come from across, right, China and other places. So there was a lot of potential to develop these things in India, and we could have done a lot actually, right, if we had technologies and to do this. But what happened is that we just borrowed the technology from outside panels, and then we just do screw technology only, and then we supplied it globally. So there should be a system, and then there should be investment happening into this. I think there are bigger companies that are doing this, and multiple, right, more companies should come forward and then do this to increase the production capability so that you can meet the goal itself. And coming back on the technology front of it, actually, yes, if you look at LDS solar panels for generating about 200 watts to 300 watts, and now we are talking about 650 watts per module actually. And this can even take to about, right, even a kilowatt also actually, right. So when the technology innovation is happening, at the same time, right, if you have the manufacturing hubs here and the technology absorption actually here, then definitely, right, we can meet these goals.
Yeah, absolutely. Okay, I mean, there is one final question from the member of the audience. Maybe, Sambit, Intel has actually been doing a lot of things in formally adopting sustainability goals. So, rather than I would pose the question to Satya, what do you think startups and smaller companies can do to formulate a policy on sustainability?
I think best thing is what basically my earlier company and what IRAM, we talked about a lot of things similar because my earlier company was doing exactly what IRAM is doing, right? So I think they need to find solutions to basically sustainability problem. That's the best the startups can do. The previous question about basically solar power for entrepreneurs, there is a big opportunity in the power electronics area. Solar panels generate the power, but then it has to go through microinverter and this and that, right? I think there is newer technology like GaN and silicon carbide has opened up a lot of opportunity to do innovation by startups in the power electronics area. And I think they should basically catch up because that is the area where we are not too far behind, like fab and all of those things, right? The compound semiconductor is something we can catch up very early. So if our entrepreneurs can start developing different type of charging devices, AC to DC converters, and basically it goes all the way from basically mobile chargers to electric trains, right? I think that's a very exciting area which is coming up very fast, and it's a good area for entrepreneurs to get into as well, because it's not like solar panel type of investment type thing, right? Those are the things for entrepreneurs.
Absolutely, Satya, you hit the right word, exciting. These are exciting times for us engineers. and all of us, okay, together, we can help change the world and make all the sustainability goals come true. Thank you so much.
Yeah, Venkatesh, I just want to add, because it came up again and again. I think what startups can do also drive that energy efficiency, whether it is in silicon, software, systems, IPs. I think if we are able to bring that down significantly, that will also help sustainability quite a bit.
Fantastic. Thank you so much, Sambit and Satya and Uday. And thanks, Gaurav, for bringing us all together. And I wish everybody who's listening in, you are the best of possible times to innovate and change the world. Goodbye.
Thank you very much.